So we're at section 3.4, part B. This is factoring sums and differences of higher powers. So to start, we recall how to factor a difference of squares. Those were the binomial conjugates. Remember, this is going to factor into x plus 5, x minus 5. You need a positive 5 and a negative 5 to multiply to negative 25 and to add up to 0x in the middle. So that's what we have, the difference of those two squares. Okay. So we're going to factor each of the following using part of the pattern here from the sum for the difference of two squares. The first one is a difference of two squares. It just has a variable in both positions. It's going to work exactly the same way because 16x squared and 9y squared are both perfect squares. So we're just going to go ahead and do 4x plus 3y and 4x minus 3y. Exact same pattern. I just haven't seen before in this class anyway, a variable in both positions, but it doesn't treat it any differently. You know that 16 is a perfect square, it's 4 squared, 9 is a perfect square, it's 3 squared, so you can factor into the two, these are called binomial conjugates. These are the same two terms with an opposite sign in the middle. Okay. Now, the next one is also a difference of squares, but if I write my formula for factoring, let's just call them a and b, so a squared minus b squared, if I write my formula as a plus b, a minus b, I want to be able to identify what a and b are in this case. What is it that is squared here in each of these cases? So the a that is squared is x squared, right? X squared squared is x to the fourth, and the b would be 9 because 9 squared is 81. So if I factor this, it's going to be x squared plus 9 and x squared minus 9, right? Now, x squared plus 9 is prime because you cannot factor a sum of squares. There's no way to multiply to a positive and add to 0. You need one positive and one negative to add to 0. You can't make a positive with one positive and one negative, but you can continue to factor the x squared minus 9 piece. It's, again, a difference of squares. So you're going to get the x squared plus 9, leave it alone, and then you're going to get, since 9 is 3 squared, you're going to get an x plus 3 and an x minus 3. So continuing this pattern, we're going to hopefully be able to factor the next one. I want to figure out what a is such that when you square it, you get 4m to the 6th. The 4 part is easy because 2 squared is 4. The m part, if you want to square it or unsquare it, you would have the number, so that would be m cubed, right? M cubed squared is m to the 6th. Same logic, the b part, what squared is 49? That would be 7. How many n squared are n to the 10th? That would be n to the 5th. If you double that, if you square that, remember squaring, just for checking, remember that m to the 3rd squared is m to the 6th, right? So m to the 3rd is part of our a. When you square something, you multiply the power by 2. So 5n multiply the power by 2 gives me the 10 for the power. This is going to look like a, so 2m cubed plus 7n to the 5th and 2m cubed minus 7n to the 5th. All right. Similar logic on the next one. I want to figure out what a and what b are. So a, first of all, if I've got x to the 8th there, I need x to the 4th, because when I square x to the 4th, when I double it, I get x to the 8th. And 1 is always 1 to any power, so 1 to the 2nd is still 1. So I'm going to separate this into x to the 4th plus 1 times x to the 4th minus 1. Similarly to part B, x to the 4th minus 1 is still a difference of squares. It's a difference of squares with the a value of x squared. And 1 is still b because 1 squared is still 1. So you're going to have your x to the 4th plus 1 times your x squared plus 1, x squared minus 1, your binomial conjugates. But then, this one is still a difference of squares, x squared minus 1, because a would be x and b would be 1. So you're going to have x to the 4th plus 1 times x squared plus 1 times, again, binomial conjugates for x squared minus 1 gives me x plus 1, x minus 1. So I could use 3 different levels. Sorry about the off the page there. 3 different levels to get this one factored. Okay. And the last page for last page of the whole unit, last page for part B in all of our notes, we're going to be comparing the difference of squares and the sum and difference of cubes techniques. Okay. So factor the following completely. So the difference of squares, x squared minus 64, factors into binomial conjugate. So that factors into x plus 8 and x minus 8. And that's because 8 squared is 64. So that is a difference of 2 squares. 64 happens to also be a difference of cubes because 64 is 4 to the third. So I could do an a value here of x and a b value here of 4 for the difference of cubes formula. Difference of cubes is going to be x minus 4, a minus b times a squared, so that's x squared, plus ab, so 4x. And last, plus b squared, 4 squared is 16. So these factor differently, obviously depending on the power of x. Difference of squares factors into 2 binomial conjugates. Difference of cubes, I need that formula. And again, I'll just write it up here, what I did real quick for that formula. I knew that a cubed plus b cubed can be factored, and I know that a cubed minus b cubed can be factored. I'll just write the minus one first, that's the one I just used. And that factors into a minus b times a squared plus ab plus b squared. Okay. The a plus b factors into a plus b times a squared minus ab plus b squared. Again, you will be given this on your test, but if you're interested in learning how to memorize it, what I noticed is that the a cubed minus b cubed keeps the same sign, and then it switches to a positive here. Okay, same thing here. You keep the same sign for the positive, and then you switch the sign in the middle. That's just the easy way to remember them. The last one's always positive. The 2 squared ones are always positive because if you square negative or positive, it doesn't matter, you get positive. Okay, so it goes minus, minus, plus, and plus, plus, minus. All right. The next one, x to the 6th minus 1, I need to decide if I'm going to do a difference of squares or a difference of cubes. And the correct answer should be that I should do a difference of squares here. Break this into 2 binomial conjugates. So let's see, this is x. Okay, if I break it into squares, it would be x cubed, right? It's because x cubed squared is x to the 6th. So the thing that I'm breaking it into for my difference of squares is going to be x cubed, and again, just 1 because 1 squared is 1. Okay, so I'm going to have x cubed plus 1 and x cubed minus 1. You always want to break down a difference of squares, if possible, before you would do a difference of cubes. So I now notice that I have 2 different of cubes this here, a difference of cube and a sum of cubes, so I need to break down. So this next piece, x cubed plus 1, has an a of x and a b of 1. So I'm going to have x plus 1 using the a cubed plus b cubed formula times a squared, so x squared minus 1x plus 1. And also need to factor a difference of cubes. That one's going to be x minus 1 times x squared plus x. Plus 1 squared is 1. Usually we rewrite this just to put the 2 binomials first, the x plus 1, x minus 1, and then the x squared minus x plus 1 times the x squared plus x plus 1. Okay, so I said a moment ago that if I can do either a difference of squares or a difference of cubes, I need to do the squares first. I could have done a difference of cubes on this one because x squared cubed is x to the 6th also. And I'm going to show you why that's less effective in the next one. In the next one, because this is a sum, I cannot do a difference of squares. I can only do a sum of cubes. And so because I know that x squared cubed is x to the 6th, then a is x squared and b is 1 in my sum of cubes formula. So my sum of cubes formula, I'm going to have x squared plus 1 times x squared minus, x to the 4th. I did that one incorrectly. That was supposed to be a squared. So x squared squared is x to the 4th. Then minus a times b, minus x squared, then finally plus 1. Now, just to think a little bit ahead or back, Had I done this one, part C, the same way as part D, I would have had the signs reversed. I would have had x squared minus 1 here, which I could have factored into the x squared, or the x plus 1, the x minus 1. But I would have had a fourth power here. It would have been x to the 4 plus x plus 1 in this case. But I would have had no way of breaking that into these two trinomials. That's why I have to do the difference of squares first. Because I can break it down into two separate pieces first and break those separate pieces down into two more pieces. I can't do the same because I can't factor a trinomial in the same way I can factor those two little binomials. Okay. This one's done because it was the sum. I can't do any more with that. But I really had to make sure that I always try factoring difference of squares before cubes. And that's the end of the whole unit and the whole course. Yay! Hope you enjoyed it.